Hi, welcome to another video tutorial in which I'll be going through a comparison of secondary storage devices. For GCSE and A-level computer science, you need to be able to compare and contrast secondary storage devices in context. So you'll generally be given a scenario and you'll be asked what type of secondary storage device is most appropriate to use in that scenario. But this information here, when I'm comparing secondary storage devices, will help you to make that decision. So I'm going to be looking at magnetic hard drives, solid state hard drives, and optical discs. And if you want to know how these work, you should take a look at how my other video tutorials on the specifics of how a magnetic drive, a solid state hard drive, and an optical disc works. But let's move on to looking at comparing them then. So in terms of capacity, magnetic depth drives have a very high capacity, highest of all three of the types of storage device we've got here. It's not uncommon now to have a magnetic hard disk which is 1 to 4 terabytes in size. That's between 1,000 and 4,000 gigabytes. Very large capacity. Solid state hard drives have a lower capacity, generally nowadays around half a terabyte to a terabyte. And optical drives have a lower capacity than either solid state hard drives and magnetic drives. Optical discs, even Blu-ray ones, are the highest capacity, and even those have only got around 25 to 50 gigabytes of storage available. Okay, so let's move on to looking at price. And what I've done here is looked at the price per gigabyte. So if you're buying, say, a magnetic drive, how much does each gigabyte cost you to purchase? And what I did here was I looked at some top shopping results on a Google search and compared the price with the capacity of the device. So magnetic drives, the cost is very low. The price per gigabyte of the drive that I was looking at was 3 pence, so very low indeed. For solid state hard drives, we've got a price which is relatively high. The cost of the SSD that I was looking at was 28 pence per gigabyte. But this is much lower than it has been in previous years, so the price of SSDs has come down massively, so it's not so much of a consideration, the price nowadays, but it is still a much higher price than a magnetic drive. And optical drives, the price per gigabyte that I was looking at was lower than an SSD, but slightly higher than a magnetic disk at 6 pence. So around 6 pence per gigabyte. Okay, so let's move on to take a look at performance then. So performance of magnetic drives, relatively slow read-write speeds you're going to get on a magnetic drive compared to an SSD, for example. For an SSD, you're going to have relatively fast read-write speeds, so much faster than a magnetic drive. And for optical discs, you're going to have relatively slow read-write speeds, again, as with magnetic drives. Okay, so let's move on to taking a look at durability then, and what the relative durability is of each of these devices. So with a magnetic drive, you've got sort of a medium-ish durability, because although it's encased in a the actual discs are encased in a metal case, you've often got a circuit board on the outside which you don't want to damage and can easily be damaged, and the discs with a high enough force will smash and you'll lose all your data. So not very high durability, but not particularly low either. Solid state hard drives have a high durability because you can drop them and they'll be fine. Throw them about to a certain degree and they won't be damaged. so much higher durability than a magnetic drive. If you dropped a magnetic drive, depending on how high the drop was, it might not work if you tried to use it again. And optical drives then, they've very low durability really. This is just purely because you can scratch them, and that can cause the data to be corrupted stored on them, and even being exposed to too much sunlight could cause corruption of the data stored on the optical disc. So not very high durability for optical discs. Let's go on to look at power usage. Then this is coming into price, but more in terms of the running cost of the device. So the power usage of a magnetic drive is relatively low. It's higher than a solid state hard drive. So this is, I would say, very low. So very low power consumption for an SSD, and slightly higher for a magnetic drive, but not dramatically higher. But if we go over to optical discs, these have a very high power consumption. Not obviously the disc itself, but the optical drives that you place them in to read and write them generally have a much higher power consumption than solid state drives or magnetic drives. And then finally, let's go on to look at portability. So portability of a magnetic drive, not really very portable at all. You wouldn't want to be, certainly an internal magnetic hard drive, you wouldn't want to be trying to take that around with you. It's going to get damaged if you're not really careful with it, and it's not very convenient to be moving about. Solid state hard drives, however, very portable. So good portability. It's because they've got a high durability, so it doesn't matter if they get knocked about when you're transporting them. They'll almost certainly still work when you try to use it again. And optical discs, again, a good portability, and this is generally because as long as you keep them in a case so they don't get scratched or anything, they're very light and are not, unless you subject them to really large forces, going to shatter particularly easily. As long as you keep them relatively secure when you're transporting them, they're going to have reasonably good portability. Okay, so that's just a overview really, or comparison of different secondary storage devices. As I say, you're not probably going to be tested on this knowledge directly, but what it's going to be is in context. So in the exam, a question will ask you what is the best secondary storage device to use for this purpose in this particular scenario, and you'll have to use this knowledge that I'm giving you right here to make that decision. So this is important. Probably won't be tested directly, but indirectly through a scenario in a question. Okay, so I hope you found this video useful. Thanks for watching.